So today we'll be solving 2020 October-November paper 42. Yeah, 2020 October-November paper 42. Let's start. Two particles P and Q of masses 0.2 kg and 0.5 kg, okay, are at rest on a smooth horizontal plane. Okay, so this is a smooth horizontal plane. This is particle Q, this is particle P, this is particle Q, 0.2 kg, 0.5 kg. P is projected towards Q with speed 2 meter per second. Okay. So P will be projected towards Q with a speed of 2 meter per second. Write down the momentum of P. So in order to find the momentum, we will do nothing but use the formula. We know the formula of momentum is mass into velocity. So the mass of P is 0.2 kg and the velocity of P is 2 meter per second. So the momentum is denoted by rho is equal to 0.2 into 2, which is 0.4. And now we'll have to include the units. That's why I wrote this here. So meter into velocity will be kg into velocity is meter per second. So meter per second. So the units are kg meter per second. Next, after the collision, P continues to move in the same direction with speed 0.3. Find the speed of Q after the collision. Okay, let's make the diagram again. So this was the before collision diagram, and let me draw the before collision diagram again. Here is P, here is Q, 0.2 kg, 0.5 kg, moving with the speed of 2 meter per second. Okay, and then after this is before collision. This is collision, this will be collision, and this will be after collision. So when they collide, when the balls are colliding, P and Q will be somewhere over here. Yeah, they collided. And what will happen next? What have they mentioned now? That as they collide, P continues to move in the same direction with speed 0.3. So P continues to move in the same direction with speed 0.3 meter per second. And what about Q? Find the speed of Q after the collision. So the speed of Q, we don't know. Let that be x meter per second. So now what the formula that we can use, and this is a pretty basic question, is initial momentum equals final momentum. I'm just writing Im equals Fm here, but in the exam, you'll have to write initial momentum equals final momentum, the entire word, in the entire words. So the initial momentum will be this 0.2 into 2, because this q is still, so it will have no velocity, and since momentum will be 0. So initial momentum is 0.2 into 2. Final momentum will be mass of P is 0.2 kg, mass of Q is 0.5. So the final momentum will be momentum of P plus final new momentum of P plus momentum of Q. So it will be 0.2 into 0.3 plus 0.5 into X. So what we can do is we can take this here minus 0.2 into 0.3 and 0.5 below it. Now if I put this in the calculator, 0.2 into 2 minus 0.8 into 3 upon 0.5. Okay. So the answer in the calculator which I got is 0.68 meter per second. So the answer is 0.68 meter per second. And that's how we end the question. And let's move to the next question. 0.68 meter per second. A car of mass 1800 kg is traveling along a straight horizontal road. Okay, let's start making the diagram. A car on a straight horizontal road. So this is a car without wheels. Mass is 1800 kg traveling. Power of the car's engine is constant. Let me write that down. P equals constant. Constant resistance to motion of 650 Newton. Let me write that with a red pen because red means resistance. So 650 Newton resistance. That means the car is moving forwards like this. Okay. Find the power of the car's engine. Given that the acceleration, okay, acceleration is 0.5 meter per second square. When it's speed, okay, speed is also given. Speed is 20 meter per second. So now we know a thing or few about this. We also know that it is not mentioned here, but because the engine is applying power, what will that lead to? That will lead to a force. Which force? It will lead to a driving force. Well, let me write that as FD. Now there are three forces that you need to make sure that you know about here. One is FRS, FD, and FR. I'll go with FR first. That is a resistance force, which is 650. The other is FD, which is the driving force, and that is caused by the power of the car's engine. And next is the resultant force. The resultant force is nothing but the resultant force of driving force minus resistance force. Okay, so we'll move ahead. The power of the car engine. Okay, this is done. So what you have to do is find the power of the car engine. So the power we can find by power of the engine is equal to the driving force of the engine, which is FD, into velocity. So the power of the engine will be driving force, which we don't know, into velocity, which is 20 meter per second. Now, can we find FD? Of course we can. How? In order to find FD, we'll have to go to FRES. Force, resultant force will be driving force minus resistance force. We know that because the resultant will be force driving minus resultant. And what is F resultant formula? Mass into acceleration, which will be 1800 into 0.5. So 1800 into 0.5, which is 900 Newton. So 900 is equal to driving force minus resistance force. Now we know resistance force, of course. That resistance force is 650 Newton. So instead of FR, I can write 650 Newton. And hence I can find the driving force easily now. The driving force will be 900 plus 650, which is 1550 Newton. So the driving force is 1550 Newton. Now going back to our previous equation, power of engine is equal to driving force into 20. So power of engine will be 1550 into 20. Now if I put 1550 into 20 in the calculator, the answer I'll get is 31,000 watts. Next question. Find a next. Find a steady speed which the car can maintain with the engine working at this power. So steady speed means speed should be constant. And we know that when speed is constant, the resultant force is zero. Okay. So now what do I mean by that? When resultant force is zero, and we know that resultant force equals Fd minus Fr. So 0 equals Fd minus Fr. And because this will turn to Fd equals Fr, we know that Fr is 650 Newton. So Fd equals Fr, which is equal to 650 Newton. So the new driving force will be 650 Newton. Why did we get a new driving force right here is very important to understand. It is because the new condition mentioned here was steady. The speed is steady. That means the speed is constant. And according to Newton's second law, when the speed is constant, the resultant force acting on the object is zero. And as the resultant force is zero, we can say that if we also know that resultant force is Fd minus Fr, which is driving force minus resistance force. So according to some basic algebraic manipulation, we got 650 Newton FD. So as driving force is 650 Newton, we now know power equals force into velocity, power of engine and driving force here. And the car can maintain with engine working at this power. This power means which power? The power which we found out in the previous question. So now we know the power, we know the driving force, we can find the velocity, constant velocity. So the power is 31,000. Driving is equal to driving force is 650 Newton into velocity. Therefore, velocity will be 31,000 upon 650. So the new steady constant velocity is 47.7 meter per second. Now let's move to the third question. Okay, this is a question relating to resolving forces. A block of mass mkg is held in equilibrium below a horizontal ceiling by two strings, as shown in the diagram. Okay, as shown in the diagram. One of the strings is inclined at 45 degrees, this one, and the tension in the string is T Newton. Okay, done. That the string is inclined at 60 degree to the horizontal and the tension is 20 newtons. Okay, so nothing, no other additional information other than the diagram. Find T and M. Okay, this T and this M. So first of all, let me make this a little bit bigger. Okay, and now the first thing we need to understand is we need to resolve forces. And what do I mean by resolved forces? If I tell you that I have a force that is 30 Newton acting under an angle of 30 degree, and if I tell you resolve, then what will you do? What will you do is you will take two perpendicular sides of the resultant force, which is 30 Newton, at a 90 degree here, and use trigonometry to solve it. For example, if this is y, this is x. So I can say sine 30 is y upon 30. Therefore, 30 sine 30 is y. Similarly, cos 30 is adjacent upon, so adjacent side is x. Cos 30 will be x upon 30. So 30 cos 30 will be x. So I can say y will be 30 sine 30 and x will be 30 cos 30. This is called resolving the forces. So now that you have understood what resolve is, let's go ahead and resolve the T Newton force and the 20 Newton force. 1 second, let me erase this. Okay, but before resolving, let's just be clear with one detail that this mkg, the force due to its weight will be mg Newton. Okay, now that we are clear, let's go ahead. So let's first resolve this 20 Newton force. How will we do that? Again, we'll draw two perpendicular vectors. One will be the force acting upwards and one the force acting to the right. That will lead to this 20 Newton force. Okay, now let us make this individual diagram again. This is 60 degree. This is 90. This is 20 Newton. So let me label this as X, this as Y. So now what can I do is I can use sine. This is the opposite side. 1 second. Yeah, sine 60 is equal to y upon 20. So y will be 20 sine 60. So what I got is y is 20 sine 60. And what about x? What about x? For x, we'll use cos. So cos 60 is equal to x upon 20. Now this 20 will go up. So it will become x equals 20 cos 60. Hence x is 20 cos 60. And now that we are done with this, let me mention it here. 1 second. Let me erase everything. Yeah. This will be 20 cos 60. And with the purple pen, this upward acting force will be 20 sine 60. Now let's go with this diagram. Again here we can make a triangle. One will act up, the one arrow will act up, one will act on the left, and this will be 90 degree. Let me redraw it here. Okay, this is T Newton. This is, let me label this as Y. Let me label this as, no, not Y this time, because I've already used Y. Let me label this as A, B. Okay, what am I missing? The angle. This angle is 45 degree. This is 90 degree. So we'll use trigonometry again. I'll use brown color. So if I use sine, this is the opposite side. Sine 45 is equal to alpha upon t. So t will go up. So a is t sine 45. I can write a as t sine 45. And what about b now? So for b, what will I have to do is I'll have to use cos. So cos 45 will equal b upon t because b is adjacent. So t is equal to, if I put t up, t will be equal to, t cos 45 will be equal to b. So b is nothing but t cos 45. Or let me label that here. Let me first erase this green color diagram. Okay, we are done. Using the orange color, I label this t cos 45. And using a brown pen, I label the upper one as t sine 45. Okay, now that we are done, let me zoom out a little bit and let us now consider all of the resolved forces. So now this T Newton does not matter to her, matter to us because we have resolved it into two components. Even this 20 Newton does not affect us. So there are now, let us make a chain, or let us differentiate vertical forces with horizontal forces. So now there are two horizontal forces, T cos 45 and 20 cos 60. So let us label that down. With the orange, I'll write T cos 45, and with the pink, light pink, whatever it is, I'll write 20 cos 60. And now let's go to the vertical forces. So there are three vertical forces. One is T sine 45, second is 20 sine 60, third is mg Newton. So let me write that down here. With the brown pen, I'll write T sine 45. With the purple pen, I'll write 20 sine 60. And with the same purple pen, I'll write mg Newton. This n is not required, does not matter, mg. So now what we have to do is you have to find Tmn. So let's make equation for this. And how will we do that? Here we know that the system or the block of mass is held in equilibrium. And what does equilibrium mean? When any system is in equilibrium, the resultant forces, F resultant is zero. And if F resultant is zero, then the forces on the left will equal the forces on the right. And the forces acting upwards will equal the forces acting downwards. So now we can make two equations. One will be T cos 45, which is this orange, is equal to 20 cos 60. And the second equation is T sine 45 plus 20 sine 60 is equal to mg. T sine 45 plus 20 sine 60 is equal to mg. Okay, so now we can easily find t using this equation. But the only thing that we need to do is we need to make t the subject. So t will be equal to 20 cos 60 upon cos 45. If I put this in the calculator, the value for t I'll get is Let me put that in the calculator. Yeah, the value is 10 root 2, which is 14.1 Newton. Now let's go ahead. So instead of this t, I can write 10 root 2 now. So I'll do nothing but 10 root 2 sine 45 plus 20 sine 60 equals to 10m, because this g is 10. Now do nothing but take 10 down upon 10. The 10 multiply here goes down and becomes divided by 10. Basic grade 8 mathematics, grade 6 mathematics. Now if I put this in the calculator, the answer I'll get is m is root 3 plus 1, or m is 2.73 kilogram. 2.73 kilogram. Okay, we are, once again, let me rewrite this. 2.73. We are done with the second question. Oh, we are done with the third question. Let's move to the fourth one. The diagram shows a velocity time graph which models the motion of a car. Okay. The graph consists of four straight line segments. Now, what do they mean by four straight line segments? This is the first straight line. This is the second straight line. This is the third straight line. This is a fourth straight line. Okay. So these are the four straight line segments. The car accelerates at a constant rate of 2 meter per second from rest to speed of 20 meter per second. Okay, so that means here the acceleration was 2 meter per second over a period of t seconds. Okay, perfectly fine. It then decelerates at a constant rate for 5 seconds. Okay, so that means it is decelerating for 5 seconds. That means this time is 5. And because this is 5, this right here will become t plus 5. Okay, now we are done with this. Before traveling to a constant speed of v for 27.5 seconds. Okay, so first the car accelerates at 2 meter per second, then it decelerates for 5 seconds, and then it travels at a constant speed v, which is this constant speed v for how many seconds? 27.5. That means here the car, for how much time is the car traveling at a constant speed? The car is traveling at a constant speed for 27.5 seconds. So that means this distance will be 27.5. So if I want to mark here t plus something, so this will be nothing but 5 plus 27.5, which is 32.5. So this point exactly will be t plus 32.5. The car then decelerates to rest at a constant rate over a period of 5 seconds. Okay. So let me rewrite this also. This will be t plus 32.5. And this, it decelerates for 5 seconds. So if this is 5 seconds, then this will be t plus 37.5. Why? Because t plus 32.5 and plus additional 5 seconds, which is t plus 37.5. Okay. So we have covered the entire diagram. We have written down all the necessary points, which will be helpful in order to get to the final answer. Because if we have not included everything like this, then we would have been doubtful about the values at the x. But now we have a hint of what is happening every time. For example, this is happening for 5 seconds, deceleration. Then constant speed is happening for 27.5 seconds. Then again deceleration happening for 5 seconds. So the first question is find t. And then what is this t? This is the time t for which the acceleration, constant acceleration is 2 meter per second square. The final velocity is 20 meter per second. And the initial velocity is 0 meter per second. So I guess after seeing A, V, and U, it may have already clicked you that we can simply use V equals U plus AT to find the time taken for this acceleration. This will be the T. So V will be nothing but 20 equals 0 plus acceleration is 2 T capital because you have to find T. So 20 equals 2T. Therefore, T equals 10 seconds. So that means the acceleration is happening for 10 seconds. And now everything is clear. Once we know that this is 10 seconds, we can also say that this will be 15 because this is taking an additional 5 seconds. And as you know, this is 15, we can say this will be 30, this will be T plus 32.5. That is T is 10, 10 plus 32.5 is 42.5. And we know that this is T plus 37.5. So T is 10. So 10 plus 37.5 will be 47.5. Okay. So now we know every detail about the timing. So let us write down it perfectly. So this T is 10 seconds. This is 15 seconds. This is 42.5 seconds. This is 47.5 seconds. Okay. Now we are crystal clear with our graph. Oops. I removed the indicator. Yeah, 42.5. Exactly below this. Yep. Now let's go forward and see what they're asking for. Given that the distance traveled up to the point at which the car begins to move with constant speed. Okay, first let us process this much. Given that the distance traveled up to the point at which the car begins to move with constant speed. That means up to this point, up to 15 seconds. Why? Because they have told the distance up to the car moves at a constant speed. And because after 15 seconds, the car starts to move at a constant speed at V. So let this be S1. And by S, I mean distance. Is one third of the total distance traveled. Okay. So the entire distance traveled. Let me label it with an orange one. The entire distance traveled will be S2. And what they are telling is S1, which is this, is one third of S2. So S1 is one third of S2. And they have asked us to find V. Now, what is V exactly? V is the point after which the car starts to move starts to move in a straight line. Okay, so now let's start finding S1 and S2. So what will S1 be? Let me erase everything first. Okay, let's talk about S1. So this part is S1. Yep. So what we can do is we can break this into two parts. What I need you to know is area of a trapezium is half into sum of parallel sides into height. That's what I need to know. And in this case, if I take this as A, B, C, D, and E. So area of the trapezium will be half into these two are the parallel sides, A and B. So A plus B into E. So this is the equation of the area of a trapezium in case you did not know. And why am I telling this to you? Because if you see right here, this shape is a trapezium. So we'll need that in order to find the area after in a while. So I mentioned it to you previously. So first we can find the area of this triangle. So area of the triangle will be half into 10 into 20, which is this 10 and this 20. And the area of this trapezium will be half into sum of parallel sides will be, this is one side, this is the other side. Oh, wait. Yeah. This is one side, this is the other side. So the one side height is V, as we can see here. So V plus, and the other side's height is 20 into height. What will be the height here? This will be the height. The height is 5. Why? Because 15 minus 10 is 5. So height is 5. So what is S1 exactly? S1 will be half into 20 into 10, which is area of triangle. Not this triangle, a right angle triangle which was formed right there. Area of triangle plus area of trapezium, which was half into V in half into V plus 20 into height, which was 5. And now let's talk about S2. So what is S2? Before talking about S2, I'll have to clear up all this mess here. Think of what is S2. S2 is the entire height, the entire area covered. So S2 will be nothing but, let me use a different pen. Yeah. This is S1 and this is a rectangle that we can see here. This is a rectangle. So we can solve the area for this rectangle. That will be area of a rectangle is equal to length into breadth, where this is the length and this is the breadth. What about the length? The length will be 42.5 minus 15 into what will be the height? We can even say breadth or height. The height will be V. And this triangle now, what will be, in order to solve this triangle, half into length. Length is 47.5 minus 42.5, which is 5 into height. What is the height? The height is V. So half into 5, not 5, sorry, half into 5 into V. So now we know that S2 equals S1 plus S1. How much is S1? S1 is nothing but this plus 42.5 minus 15 will be 27.5. 27.5V and 5 upon 2 will be 2.5V. Because if you put 5 upon 2 in the calculator, you will get 2.5. So 27.5 plus 2.5V. So 27.5V plus 2.5V. Yeah. And now let me equate both of them. S1 equals 1/3 of S2. Now let's simplify S1. What is S1? Now we can see this half into 20 can, this half, 2 will become 1 and 20 will become 10. So S1 will be 10 into 10 is 100 plus 5 upon 2 V plus 20. Now we can even simplify this. We can multiply both here. Therefore, 100 plus 5V upon 2 plus 5 into 20 upon 2. 1 10 za. So therefore, S1 will be equal to 100 plus 5V upon 2 plus 5 tens are 50. And this 100 plus 50 will become 150. 100 plus 50 is 150. So now we know that S1 is equal to 150 plus 5V upon 2. Now let's talk about S2. What is S2? We already know that S2 equals S1 plus 27.5E plus 2.5E. 27.5 plus 2.5 will give us 30. So S2 is nothing but S1 plus 30V. Why 30V? Because don't forget the V sign here. So, and what is S1? S1 is 150 plus 5 by 2. So S2 is nothing but 150 plus 5v upon 2 plus 30v. This is S1 and this 30v. Therefore, S2 is equal to 150 plus 260. This will become 65v by 2 after simplification. So we have both the most simplified versions of S1 and S2. So now let's use our equation. Which equation? S1 equals S2 by 3. Therefore, S1 is 150 plus 5v by 2. S1 equals S2 upon 3. S1 is 150 plus 5v by 2 and S2 is 150 plus 65v upon 2. Answer into 1 upon 3. Now what we can do is we can multiply 1 by 3 by both of them here, which will give us 150 plus 5v upon 2 is equal to, this is therefore 150 plus 5v upon 2 will give us 150 upon 3 into, 150 upon 3 plus 65v upon 6. Therefore 150, let me use a different pen. 150 plus 5v upon 2, 150 by 350 is equal to 50 plus, we can divide it by 3 is able to, no, we can't divide it, my bad, plus 65v upon 2, upon 6. Now this can go there and 50 will come here. So 150 minus 50 is equal to 65v upon 6 minus 5v upon 2. And 100 will be equal to into 3 into 3. So 65v minus 15 upon 6 minus 15v. Therefore 100 into 6 is equal to 65 minus 15 is 40. My bad, 50v. Therefore 100 into 6 upon 50 is equal to v. 1 2 Therefore the final answer now v will be 2 6 12 meter per second. And here our fourth question is completed. Let's move to the fifth question. A particle is projected vertically upwards with a speed of 40 meter per second alongside a building of height 4 h meter. Now, in the fourth statement itself, I want you guys to understand that many children will not read the question. They will hurriedly just or see all the values and start solving. Now, a very important detail here is the particle is projected vertically alongside a building, not on the building. Normally, what question comes is here a building is there, the particle will be here. But here in this question, what they have asked is the particle is placed alongside a building and it is projected. That means the particle will be somewhere here. That's very important and what you need to understand. And it is projected vertically upwards with a speed of 40 meter per second. And what is the height of the building? The height of the building is h. Okay, now we'll go ahead. Given that the particle is above the top of the building for 4 seconds, find h. Okay, so that means the particle will eventually go up. The particle is going up, going up, going up, going up. It will reach somewhere here. Again, it will go up, go. It will reach its maximum point and it will come down and it will reach here. So the time taken for this to happen is 4 seconds. That means the displacement of the particle will be greater than h for 4 seconds. This is a very important point. You need to understand the particle will be above height h for 4 seconds. That means going up also and going down also. Now we'll go ahead. What they have asked us to do is they have asked us to find h. How will we find h? First of all, what you need to understand in this will be that the particle is up above h for 4 seconds. What does that mean? The time taken for the particle to go up will be 2 seconds, and the time taken for the particle to go down will be 2 seconds. This is the first thing you need to realize. I'll repeat it. The time taken for the particle to go above height h will be 2 seconds, and the time taken for the particle to go below to reach point h will be 2 seconds. Why? Because total time is 4. 4 divided by 2 is 2. So half the time in going up and half the time in going down. That is the first thing you need to realize. And now let's move to the second thing. And why is this? Because let us assume an object is at this point here. And from this point, if it takes 3 seconds in a free fall, if let this be 3 meters, and the particle takes 3 seconds for going up, then of course it will also take 3 seconds for going down. And in the question, it can be a little twisted. What did I tell? That the total time is 6 seconds. That means 3 seconds it took for the particle to go up and 3 seconds it took for the particle to go down. That is what the basic logic is. Now we'll go ahead. By using V equals U plus AT. And by understanding when the particle is at its peak, that is its max height, its velocity will be 0. So now when the velocity is 0, initial velocity is 40 and acceleration is minus 10. We can find T. 0 equals 40 minus 10t. So the time will be 40 upon 10, which is 4. Therefore, time is 4 seconds. Now, what is this 4 seconds? The 4 seconds, this time is, let me write it down in English words. Time in 4 seconds denotes time taken to reach max height. Now, let me draw something on the diagram here. So now, the time taken for it to reach max height will be 4 seconds. And now we already know that this much takes 2 seconds. So what is the remaining part? The height h. So the time taken to reach height h at this point from here will also be 2 seconds. Why? Because this upward is also 2 and this total is 4. So the time taken to reach this height h will be 2 seconds obviously. So another thing we found out is time taken to reach height h equals 2 seconds. I'll explain it to you again. The time taken to reach uh, for the ball to reach its peak, that means where velocity is 0, its maximum height from from height h is 2 seconds here, right here. And we know the total time from 0 to max height is 4. So hence, by mathematical calculation, if this entire thing is 4 and if this much is 2, we can find that time taken for this much will also be 2. Why? Because this entire thing should add up to be 4, right? This thing. So hence the time taken for the ball to reach from height equals 0, that is here, to h will be 2 seconds. And now we'll go forward. Time taken to reach height h is 2 seconds. Now we know time, we know initial velocity, we know acceleration, we don't know final velocity. So what we can use is s equals ut plus half at square. We know u, we know t, we know a, we know t. Yeah. So s is h technically, height or height h. That's what we have to find, the height h. That's what they have asked in the question. Find h. H equals u is 40. T, what will T be? Will T be 4? No. T will be 2. The time taken to reach height h. Plus half. A will be minus 10. T square will be 2 square. Now 42 is 80, which is equal to 80. This cuts to become minus 5. Then minus 5 bracket 2 square is equal to minus 5 into 4, which is minus 20. Therefore, height equals 60 meter. And now we have the h, which is the height of the building. The height of the building is 60 meter. Now let's move to the next question. 1 second after the first particle is projected, the first particle means the projected particle which was going up at 40 meter per second. A second particle is also projected upwards from the top of the building. Okay, now this time the particle is being projected from the top of the building, not alongside the building, with speed 20 meter per second, denoting the time after projection of the first particle by t seconds. That means as soon as the 40 meter per second particle goes up, starts moving upwards, we have to start the timer, or we have to start the stopwatch, and that will be considered as the reference time. Find the value of t for which the two particles are at the same height of the above the ground. Find the value of t for which the two particles are at the same height above the ground. So what do they mean by that is, let me draw a diagram. We'll talk about the 1 second projection a little bit later. Let us just understand this question here first initially. There is one ball here, other ball here. This is height h. Now this ball is projected at 40 meter per second upwards. Now let me draw a stopwatch here. This is a stopwatch. Start, stop. So as soon as this 40 meter per second is thrown upwards, the stop clock starts. And after 1 second, after exactly 1 second, this ball is thrown. That means as soon as 1 second is over, as the time becomes 1 second, this ball is thrown up at 20 meter per second. And after some time, the ball will go up. When this ball will go up, and after some time, they will meet at the height, at a certain height. So the point at which they will meet a certain height, how much time will it take for this to happen? For them to meet at a certain height, how much time will it take? That's what we have to find out. Now, do not forget that we have to denote the time after projection of the first particle by t seconds. So this is a very this may be a very confusing statement for you, but I'll break it down. What does it mean? So we'll have a formula. Let's consider v equals u plus at. Okay. So now this formula is there. So how much time will it take for the 40 meter per second particle to its initial velocity is 40 meter per second. But how much time will it take for its velocity to reach 10 meter per second? Let's find out. So the time it will take is v is 10, u is 40, acceleration will be minus 10 into t. So 10 minus 40 upon minus 10 is equal to t. Therefore, the value for t will be minus 30 upon minus 10, which is 3 seconds. That means once as the timer is started, it will take 3 seconds for the velocity to reach from 40 to 10. Now, let's talk about this particle. This we talked about the 40 meter per second particle. Now let's talk about the 20 meter per second particle. How much time will it take for that particle to reach the same 10 meter velocity, but only difference will be that the initial velocity is 20 meter per second. So again, v equals u plus at, so velocity final is 10, initial is 20, plus gravity same effect minus 10. 10 minus 20 upon minus 10 equals t. Therefore, that means it will take 1 second. It will take only once. It will take 1 second for the particle to 1 second for the particle to go from 20 meter per second to 10 meter per second. But will it look in this? Will it look same in the calculator on the stopwatch? No, not at all. Why? Because let's assume this ball. As soon as it was thrown, the stopwatch started. So first 1 second speed might have been something. Then second speed I might have been something. Then third second the speed will be 10. Okay, understood. That what did we understand by this? That as we go on with the stopwatch, as the stopwatch hits 3 seconds, the speed of the particle 40 meter per second particle will turn to 10 meter per second. But what about this? Do you think if, I'll question you now. You just tell me if I correctly told it or no. That as the stopwatch it appears 1 second, 1 second, the speed will get from 20 meters second to 10 meters second as the time on the stopwatch is one. That's correct? No, that's wrong. Why? Because here we have told denoting the time after projection of the first particle by t, and they have told that the second particle is projected vertically upwards 1 second after the first particle. So that means whatever effect this will have, it will it will occur 1 second later. That means when the stopwatch will be 2, at that time the speed will be 10. Let me denote that in a graph to you. Earlier, the red will be no wait. The dark green will be the 40 meter per second, and the purple will be 20 meter per second particle. Now, what will happen? We have to denote time t. We have to denote t with the 40 meter per second particle. Oh, not here, my bad. Right now, what I'm doing is I'm drawing a velocity time graph. So I have to denote t with this 40 meter according to this time, velocity per meter per second, sir, meter per second, and time per second. So now, when time equals 0, what will be the velocity for this 40 meter per second particle? Initially, the velocity will be 40. But what about this? At time equals 0, this will have no velocity. It won't appear on the graph only, because it will appear on the graph, but its velocity will be 0. Why? Because still it is not being thrown. None of them are being thrown actually. So it will be at 0 because it is stopped here. And in just an instant, this 40 meter per second is thrown. So that means it will be something like this. And at time, let's assume this is time 3 seconds. And what we found out was in 3 seconds, the 40 meter per second particle reaches from 40 to 10. So this means if this is 30, this somewhere, 1 second, let me draw it to scale. Mm, yeah, if this is 30, not a proper graph, I'm sorry. Yeah, perfect. So if this is 40 and this is 10, that means it will take 3 seconds somewhere here. But what about the 20 meter per second? For the first 1 second, it is not being thrown at all. It is just there. And as 1 second passes, it moves at 20 meter per second. So that means the graph for this will start here. And when earlier we thought that in 1 second only from 20 to 10 meters per second it will convert. But actually, if we denote the time after the first particle, then that means it will take 2 seconds. It will take 2 seconds. So what it shows here is that here, when the time is 2 seconds, at that time the particle will reach 10 meter per second here. Now let's draw how the graph would look like if both 40 meter per second and 20 meter per second were thrown at the same time. If both 40 meter and 30 meter were thrown at the same time, then let's assume this to be 40, This will be 20. This is time 1, time 2, time 3, 4. So normally how much time does it take for 20 to turn to 10? For 20 to turn to 10, it takes only 1 second. So this 20 would have turned to 10 in only 1 second only. Like something like this. And how much time does 40 take? 40 takes 3 seconds to turn to 10. Okay. So 3 seconds. So what 40 would have turned like this. This would have been the graph if the time, if we would have considered that both are thrown at the same time. If the time at which both are thrown is same. But now here the catch is that this 20 meter per second is thrown 1 second late. So what is happening here is this entire arc is being shifted 1 second to the right. So what is drawn like this, becomes something like this. So if this is 1 second, the graph starts from here. It's the same graph, but translated. So the graph will start somewhere from here, and it will end somewhere here. So it takes 2 seconds for the particle to reach 10 seconds. It does not actually take 2 seconds, but on the stopwatch, the time will be 2 seconds. So now this, according to the 2 seconds logic, will be incorrect because time should not be 1, time should be 2. So what do? V equals u plus 80. We know this. And if we put that in v as 10, simply initial velocity 10 and minus 10 and t, then the answer for t we are getting is 1 second. So we'll have to do something to t in order to get the correct answer. We can manipulate t. And what will we do? Because the time denoted is by first particle t, and second particle is being thrown 1 second later. So we'll have to do -1. Why? Because that is being thrown 1 second later. So now the answer will change. How will it change? Now let's see. First, this will become -10 equals -10 t minus 1. -10 minus 2 will cancel out to become +1. So 1 is equal to t minus 1. And this -1 will go there to become +1. Therefore, t equals 2 seconds. Now we have the correct answer. What is the correct answer? T minus 1. What is the correct answer? 2 seconds. That means the speed will become 10. The speed will become 10 at 2 seconds. But what was the change we did? So what we have to do, I will give you a thumb rule now. 40 meter per second, we have to calculate using t. So we'll use v equals u plus 80 in this case. For 20 meter per second, we'll have to use t minus 1. So we'll have to use v equals u plus a and then t minus 1. So wherever we put t, we'll use t minus 1. Why? Because this is being translated to the right, one side. So for that, we'll use t minus 1. If the question was that the 20 meter per second is thrown 1 second earlier, not 1 second later, but 1 second earlier. If 20 meter per second would have been thrown 1 second earlier, then we would have taken t plus 1. Then it would have become b equals u plus a t plus 1. So this is what you have to remember now, henceforth for your upcoming questions. If earlier, then t plus 1. If later, then t minus 1. Write it down somewhere in your important notes. Earlier will become t plus 1. Later will become t minus 1. I took a lot of time explaining this to you because this is one of the most tricky things. Students often make silly errors. But once you practice 3-4 questions like this and you get a hold of it, it will be a piece of cake for you. So let me erase everything and let us go back to the question. So the question is, denoting the time after projection, find the value of t for which the two particles are at the same height above the ground. So here we have to consider the ground at height as h equals 0. And what do we have to find? These two particles are at the same height, assuming here. So that will be at what time? That we have to find out. First, what we need to realize is the displacement of the 40 meter per second particle should be equal to the displacement of the 20 meter per second particle. That's what is the first thing. This is the displacement. One second. This is the displacement right here. Yeah. So what is the displacement of the 40 meter particle? The displacement of the 40 meter particle can be written as ut plus half a t square. And what is u? U is 40. T, T we don't know, T we have to find out. This half acceleration will be minus 10 and t square. This can be written as minus 5. So therefore, displacement of 40 meter particle is 40t minus 5t square. Now what about the 20 meter per second particle? For the 20 meter per second particle, same u, but here instead of t, we'll write t minus 1 plus half into minus 10 t minus 1 the whole square. And now this is not the only displacement. Here we considered height to be 0 here for the 40 meter per second. And now if you want to equate both of them, here also height we will need this only. So this will be minus h. Why? Because this is the extra length, right? Because this we don't want. We just want it at the ground level. So the displacement here h is 60. We already found out the height will be 60. And so instead of minus h, we can simply write minus 60. So here instead of minus h, I'll write minus 60. Now, in order to confirm this, what can we do? We can find the displacement at the first second. So displacement at the first second will be u bracket 1 minus 1 will 0. So this entire thing is 0 plus half. This will also be 0. So is the displacement minus 60? Is the displacement at the first second minus 60? No. The displacement will be plus 60 obviously because we are going up and this height is 60. So it should not be minus h, it should be plus h. So we got our equation right here. S20 equals u bracket t minus 1. That was not a mistake. I told it forcefully so that you understand whether we should take minus or plus. And in case you did not question why am I writing minus, then you must realize that somewhere you have lost your curiosity about understanding the concept. So S20 will be initial velocity will be 20 bracket t minus 1. This will become minus 5 t minus 1 the whole square plus 60. Now let's equate both of these. S40 equals S20. S40 is 40t minus 5t square. S20 is 20 bracket t minus 1 minus 5 bracket t minus 1 the whole square plus 60. Now quickly we'll simplify everything. So it will become 40t minus 5t square equals 20t minus 20 minus 5. We'll open this bracket t square minus 2t plus 1 equal plus 60. Again, further more simplification, 40t minus 5t square is equal to 20t minus 20 minus 5t square plus 10t minus 5 plus 60. Now we can add and subtract things of 40t. This will remain the same. Minus 5t square is equal to 20t. 10t will become 30t minus 20 plus 60 minus 5. Okay, 60 minus 20 is 40. 40 minus 5 is 35. So plus 35. This is done. Then minus 5t square remains like this only. This minus 5t square minus 5t square will cancel out. The 30t will go there. So 40t minus 30t is equal to 35. Therefore, t is equal to 10t is equal to 35. Therefore, finally, time equals 3.5 seconds. Now, what does this value mean? That means at 3.5 seconds, the particles will be at the same height. And that's how we end the question. And we'll go to the next one. Sixth, a block of mass 5 kg is placed on an inclined plane at 30 degree. Okay. So its weight will be 50 Newton. Its one of the component will be 50 cos 30. And a downward component will be 50 sin 30. This is nothing but mg sin theta. This is mg cos theta. Let me erase this to save up space. Okay. The coefficient of friction and the between the block and the plane is u. Okay. So there is coefficient of friction. When a force of magnitude 40 Newton is applied, acting up the parallel line, the block begins to slide up the plane. That means the block begins to slide up. Now understand this. The block is moving up and there is friction. We know that. So where will friction act? The friction will try to resist its movement. So obviously the friction will move down. So this is Fr, which is frictional force. Show that micro is less than 1 upon 5 root 3. Okay, no problem. This is a very easy question. What we can do is we can write that because the block is moving up, we can say that the 40 Newton force, which is this upward force, will be greater than the frictional force and the 50 sine 30 force combined. 50 sine 30 force combined. We can say this, correct? And now we have to find out what is micro. And micro is less than this is. So what can we do? We know Fr equals UR. And we can find R very easily. R is the contact force, which is this one, R. So R is nothing but 50 cos 30 because there are no other external force. So both equal each other. R equals 50 cos 30. So Fr equals U into what is R? R is 50 cos 30. Therefore, 40 is greater than micro 50 cos 30 plus 50 sin 30. What I did is instead of Fr, I found this term and I wrote it here instead of Fr. So 40 minus 50 sin 30, answer upon 50 cos 30 is greater than mu. Okay. Therefore, mu is less than, and I will put this in the calculator, 40 minus 50 sin 30 upon 50 cos 30. The answer is root 3 by 5. Hence proved that mu is less than root 3 by 5. Now we'll go to the next question. B part. When a force of magnitude 40 Newton is applied horizontally in a vertical plane containing this is the block does not move. Show that correct to the 3 decimal places, the least possible value of u is 0.152. Okay. So now first thing, we'll resolve this 40 Newton force. How we do that? This is 40 Newton. This is acting on a plane like this. And there is another line given like this, and this is 30 degree. Both are parallel. So now according to alternate angles, even this will be 30 degree. Correct? And now we can resolve it very easily. This is 40 Newton. This will be 30 degree. By this I mean this angle will be 30 degree. And what can you do now is you can make two lines of slope. One will act to down, one will act to the right. This is 90 degree. And I'll draw this here once. One will act down, one will act to the right. Let this be x, this be y. So I can use sine 30. Sine 30, opposite side is y upon 40, and cos 30 will be x upon 40. So technically, X is 40 cos 30 and Y is 40 sin 30. Now Y is acting downwards. So this angle is 40 sin 30. And one is acting to the right. This force is acting to the right. This is 40 cos 30. I can draw it like this. Perfect. Now let me erase everything. Now this 40 force has no use for us because we have already resolved it. So now we have it in two planes which will be useful to us. And again we'll draw the 50 Newton. We'll resolve the weight. This will be 50 sin 30. This will be 50 cos 30. And are there any other forces? No. Yes, obviously there will be frictional force. Now there are two possible options. Either the first option is the block moves like this. The second option is the block moves downwards. So if the block is moving upwards, the FR will be down. This will be the FR. And in the first case, if the block is moving upwards, FR will be downwards. And in case if the block is moving downwards, the FR will be upwards. So we'll have to find the answers for both of them. Let us first solve the first one, considering FR moving downwards. So if FR is moving downwards, we'll have to consider this orange arrow. So 40 cos 30. Here they have told that the block does not move. That means the system is in equilibrium. That means the forces to the right will equate the forces to the left. So 40 cos 30 will equal 50 sin 30 plus FR. Now what is the formula for FR? FR equals UR. And what is this R? R is the contact force. And the contact force acts upwards. This is R. So R in this case will equal 40 sin 30 plus 50 cos 30. 40 sin 30 plus 50 cos 30. Therefore, FR is equal to U into 40 sin 30 plus 50 cos 30. So therefore, 40 cos 30 is equal to 50 sin 30 plus mu 40 sin 30 plus 50 cos 30. Now, doing some simple mathematics, 40 cos 30, taking this to the left, minus 50 sin 30, then taking this down to divide upon 40 sin 30 plus 50 cos 30 is equal to mu. Now I'll put this in the calculator. 40 cos 30 minus 50 sin 30, answer upon 40 sin 30 plus 50 cos 30. Yeah, so the answer I got is micro is equal to 0.152. Now, what this was by fluke that I considered FR to be down. What if I had considered FR to be up? And the answer I would have gotten was something else. Now, in that case, the answer would not have been 0.152. The answer would have been something else. So if I had have first taken up, the answer I would not get would be not correct. So I will do nothing. I will simply write the second possibility down. And the correct answer, finally, for example, if I have done FR upwards was written somewhere here. And my answer was 0.7, for example. Then second step, I would have done this. And in my final answer, I would have labeled 0.152 is the final answer, as it is the least possible, not least possible. What was the question? As it is the Yeah, least possible value of micro. One second. Least possible micro value. This should have been written in the last. Now, why did I select downwards? I hope you realize that 50 sine 30 is 25. I put that in the calculator and checked. And 40 cos 30, if I put that in the calculator, the answer is 34.64. That means the upward force is higher than the downward force. So if upward force is 34 and downward force is 25, then it is quite obvious that FR will act downwards only. That means in this case, if you would have considered FR to be upwards, then you would have gotten a negative answer, because some negative value plus 34.64 will give us 25. We can't add something to 34 and get 25. So in case you would have taken FR upwards, then you would have gotten negative. But the thing to remember here is, once you got 50 sine 30 and 40 cos 30, first put them into normal values, into integers, into decimal places. So you will realize that this is 34, this is 25, this is higher. That means the block will act upwards, block will move upwards. And in order to resist that, friction will go downwards. That's how you solve this question. And we are done with the second one. We'll go to we are done with the sixth question. We'll go to the seventh one. A particle P moves in a straight line starting from a point O with velocity 1.72. Okay, very important detail. Initial velocity is 1.72 meter per second. The acceleration a meter per second of the particle T leaving given by this is okay. So the acceleration is 0.1 t raised to 3 by 2. Find the value of v when the velocity of the particle is 3 meter per second. Now, just let me make a diagram. This is an acceleration time graph, not a diagram, a figure. This is a velocity time graph. This is a displacement time graph. And now reverse. Now, if I want to go from displacement time to velocity time, what will I do is derivate. Same here, if velocity time to acceleration time, what I'll do is derivate. Now, if I want to go from acceleration time to velocity time, what I'll do is integrate. Same here, integrate. Keep this in mind. Very important. Next, find the value of t when velocity of v is 3 meters per second. So now we are an acceleration time graph and we have to find t from velocity. We have to find t from velocity. So for that, from acceleration time graph, what we have, we'll have to integrate. So let's integrate the acceleration time graph, which will give us the velocity time graph, which is equal to the integral of 0.1, not 0.t, my bad, 0.1 t raised to 3 by 2 dt. Not a good ink. So velocity will equal 0.1 t raised to 3 upon 2 plus 1 upon 3 upon 2 plus 1. Therefore, 0.1 t raised to 5 upon 2 upon 5 upon 2. Now this 2 will go up. Therefore, 0.2 t raised to 5 upon 2 upon 5. Now we know plus c. Now we know what is c. For example, if this is a velocity time graph that we got, there should be a plus c here. And this is where the graph starts from. Now we know that the velocity initially starting from point is 1.72. So this c should be 1.72. That means c is 1.72. So velocity will equal 0.2 t raised to 5 upon 2 upon 5 plus 1.72. We can even prove this if we take t as 0. Then we'll be left with v equals 0 plus 1.72. And when t equals 0, the velocity is 1.72. We know that in the question. Starting from point O, that is origin, velocity is 1.72. And in the origin, the time is 0. So we have got the equation velocity is equal to 0.2 t raised to 5 upon 2 upon 5 plus 1.72. Now the next step is to find the velocity of p when, to find the value of t when velocity is 3. So here the velocity is 3, 0.2 t raised to 5 upon 2 upon 5. Now this 1.72, I'll simply make it go there. So it will become minus 1.72. This 5 can go up. This 0.2 can go down. Therefore, t raised to 5 upon 2 is equal to, now if I put this in the calculator, 5 upon 0.2 upon bracket minus 1.72 plus 3. Answer is 32. Now if I put this in the calculator, what I can do is 5 raised to 2 here goes there and becomes 2 raised to 5, which is technically reciprocal. So 32 raised to 2 upon 5 is equal to 4. Therefore, the value of t is 4 seconds. That means at the 4th second, the velocity of p will be 3 meter per second. Let's go to the next question. Find the displacement of p from O when t equals 2. Giving your answer. This is also a very easy question. We have the velocity time graph. We'll integrate it. We'll get the displacement time graph. Now, what is the velocity time graph? V equals 0.2. V equals 0.2 t raised to 5 by 2 upon 5 plus 1.72. Now, if we integrate the velocity time graph, integrating the velocity time graph, which is the integral of this, when t equals 2, so that means the limit should be 2 and 0. Now let's start integrating this. So we'll get 0.2 t raised to 5 upon 2 plus 1. One second, not a good line. Upon 5 upon 5 upon 2 plus 1 plus 1.72 t to 0. Now, if you put this in the calculator, 0.2 t, 5 upon 2 plus 1 will become 7 upon 2 and 5, 7 upon 2. This 2 will go up and 0.2 into 2 will become 0.4. Plus 1.72 t to 0. Now, if you put this in the calculator, 1 second, 0.4 into p minus this, the answer we'll get is 3.57 minus 0. This is the displacement. Displacement equals this. Therefore, the answer is S equals 3.57. So this is our final answer. Now let's go to the next question. This is the final question. It looks pretty lengthy. So let's see what it is. Two particles, A and B, of masses 0.3 kg and 0.5 kg respectively, are attached to the ends of a light and extensible string. The string passes over a fixed volume attached to the horizontal plane initially at rest. Initially at rest means u equals 0. Horizontal, B on the inclined plane, angle 30 degree. String is taut. B can move on a greatest line of flow, force of magnitude 3 Newton. Find the tension in the string and acceleration. Okay. So what they're asking us to do is find the tension in the spring. So this is the tension. And to find the acceleration of B. Acceleration of B. So let's start by making a free body diagram. Here, weight 5 Newton will act. The contact force of 5 cos 30 will act. The force will act downwards. Down the slope will be which will be 5 sin 30. And is there any other force? The planes are smooth, so no frictional force, nothing else. We are done. Not done with the question, we are done with the diagram. Okay, we'll go ahead. Find the tension in the spring. So to find the tension in the spring, what we can do is, first we can understand the free body diagram of A. So if I only draw A is 0.3 kg, and here it is attached with a spring, it has tension. It has no other force. So we all know that F resultant is equal to mass into acceleration. And here F resultant is only tension. So tension is equal to mass into acceleration. So tension is equal to 0.38. Therefore, tension upon 0.3 is equal to acceleration of A. So now we are done with this. We'll go. This was for A. We'll go with B now. For B, there are a few forces. 3.5 Newton acting. Let me draw it again. Your 3.5 Newton is acting downwards. Then 5 sine 30 is acting downwards. Then 5 cos 30 is acting like this. Tension is acting upwards. But this does not matter to us because this is nowhere affecting the speed or the acceleration of the particle parallel to the slope. So we can simply write 3.5 plus 5 sine 30 is equal to T. Or we can write firstly we can write F resultant is equal to mass into acceleration. Therefore, F resultant will be 3.5 minus plus 5 sine 30 minus T is equal to mass. The mass is 0.5 into A. Now, what I need you to understand is, for example, let's take a pulley. Both the here is one mass A, here is one mass B. Now, if B is 1 kg, A is 2 kg. So A will of course move downwards, but the acceleration at which A will move downwards will be equal to the acceleration at which A will move upwards. I will repeat, the acceleration at which A will move downwards is equal to the acceleration at which B will move upwards. Why? Because both are connected. One can't move at 5 meter per second speed and the other can move at 2 meter per second. Not possible. Both are connected to each other. That will be like, assume you have one box here. You stick it to one stick here and connect another box. Then you push one box. If this box moves at 5 meter per second, of course this has to move at 5 meter per second because both are stuck. Both will have the same velocity. So this is the both will have the same velocity, and this is the case for A and B here also. Why? Because they have told, where was it? The string is inextensible. That means both will have to move together. That means the string is like a stick, like a hard stick which cannot be stretched. And here also they had mentioned it as taut. Yeah, here taut. The string is taut. That means it cannot stretch, and both will have to move. If, for example, if this moves at 5 meter per second, even this will have to move at 5 meter per second speed. If this covers 1 meter, if this covers 1 meter distance down, 1 meter, then this will cover 1 meter distance. So by asking the acceleration of B, they are confusing us because they could have just asked to find the acceleration because the acceleration of B is equal to the acceleration of A. Okay, now we'll go ahead. And that's why we can just write A and A here. Both are the same thing. If acceleration for both of them would have been different, I would have written acceleration of A like this, acceleration of B like this, but not required. Acceleration of A is equal to acceleration of B. I hope you are clear with why acceleration of A is equal to acceleration of B. Now we'll go ahead. What we can do is we can substitute instead of this A, we can write T upon 0.3. So we'll do that. 3.5 equals 5. Oh, 1 second. Not equals, plus 3.5 plus, I'm writing this here, 5 sine 30 minus T is equal to 0.5. Instead of A, I will write T upon 0.3 into T upon 0.3. So this 0.5 upon 0.3 will become 5 by 3. So 3.5 plus 5 sine 30 is equal to 5t upon 3 plus t. So 3.5 plus 5 sine 30 is equal to t is in bracket 5 upon 3 plus 1. 5 upon 3 plus 1, if I put that in the calculator, I will get 8 upon 3. Therefore, 3.5 plus 5 sine 30, answer into 8, answer, no, 3 goes up, 8 goes down, my bad. 3 will go up, not 8, into 3 upon 8 is equal to t. Now, putting this in the calculator, the value for tension I will get is 3.5 plus 5 sine 30, answer into 3, answer upon 8. The tension is 2.25 Newton. And what about the acceleration? Acceleration will be a piece of cake now because A is t upon 0.3. Therefore, here we have already proved it. A equals t upon 0.3. Therefore, A is 2.25 upon 0.3. And so the 2.25 upon 0.3 will give me 7.5 meter per second square. 7.5 meter per second square. Next question. It is given instead the two planes are rough. Okay. Now a little bit twist will come. The two planes are rough. That means your friction will act Fr. Even your friction will act Fr. But are they the same? Let's see now. Yeah, that means friction on both sides is the same. When each particle has moved a distance of 0.6 meters from rest. Okay. So what do you mean by that? Let's assume this to be 0.6 meter. If A moves 0.6 meter downwards, even B compulsorily has to move 0.6 meter downwards. The total work done against friction is 1.1. Okay, so work done against air resistance, work done against resistance or friction is 1.1 joule. Use an energy method. Okay, very easy question. 4 free marks for us. To find the speed of B when it has moved down this plane. You should assume that string is of area. Okay. Yeah. So what we can do is there is only one energy method. Work done by driving force is delta Ke plus delta Gp plus work done by resistance force. So what is the work done by driving force? Now, even though it was not written here that 3.5 Newton is the driving force, it is obvious. Because where is this 3.5 Newton appearing from? Someone might be pulling it. It might be connected to a bench or something like that. That's why this 3.5 Newton will consider it as a driving force. So 3.5 Newton is a driving force. And what is the formula for work done by driving force? It is force into distance. And what have they told us? Distance is 0.6 meter here, 0.6 meter from rest. Therefore, work done by driving force is equal to what is FD 3.5? What is distance? 0.6. If I put this in the calculator, 3.5 into 0.6 is 2.1. What about delta K? What about delta K? Delta K also very easy one. K, what they have told us here is that mm, when each particle has moved a distance of 0.6 meter from rest. Rest means initial velocity for both particles will be 0. So kinetic energy will simply be half into m into v square. Now, because both particles will move at the same speed, we can simply add their masses, which will be 0.3 plus 0.5 into what velocity are they traveling? We don't know. That's what we have to find out, speed of v. Now, we already discussed in the previous question the acceleration of B and A, the velocity of B and A, the distance traveled of B and A, 0.6, 0.6, everything will be equal. So this is just confusion, speed of B, not required. We have to just consider the speed of both. Not so this is the kinetic energy. So work done by trying force is 2.1 is equal to kinetic energy will be half into 0.8 into v square plus delta gp. Delta gp is the change in height. So now let me tell you one thing. What they have mentioned here is assume that string is sufficiently long so that A does not hit the pulley when it moves 0.6. So when A travels 0.6, it will not touch the pulley or it won't go down the pulley. 0.6 meter is somewhere behind the pulley only. And what is the formula for GP, mgh? Now consider this height h. Has the height of A changed? No, height of A has remained constant only. So if delta h is 0, then delta GP will also be 0. That means A has no relation with GP. The only relation of GP is with B because B is moving down here. And so height is changing. So let's go to that. Now we know that the angle is 30 degree. The distance traveled like this is 0.6 meter. See, if you read carefully, they have told moved when each particle has moved a distance of 0.6 meter from rest. So it is not telling the height, it is telling it has moved this much. And this is height h. Simply basic grade 9 trigonometry sin 30 is h upon 0.6. 0.6 will go ahead. 0.6 sin 30 will be 0.3. So let me, no, I shouldn't erase this actually. I'll continue writing it down. 2.1 is equal to half into 0.8 will be 0.4 v square plus 0.6 sine 30. Okay, so this is delta GP, which will be mgh. So we won't consider the mass of A and mass of B. We'll only consider the mass of B. Why? Because only B is moving downwards. And what is the mass of B? 0.5 kg. Okay, so 1 second. Mm, mm, यार ये कंप्यूटर के So the mass of B is so the mass of B is 0.5 kg. Gravitational potential is 10. Not gravitational potential, acceleration due to gravity. And height, difference in height, delta H is equal to 0.3. Plus, what was the other thing? Work done against resistance. Now they have already told us that the total amount of work done against friction, the total amount for work done against friction is 1.1 joule. So no need to worry. We can simply write 1.1 joule here. This is the work done against friction. So now as you can see, 0.4 v square is the only remaining 0.4 v square is the only remaining variable here. So if we just manipulate the constants, 1.1 will go there minus 5 0.3 answer upon 0.4 is equal to v square. Now to remove this square, I can root it here. Yeah. So now finally the answer for v, which I'll get is, if I put this in the calculator, root of 2.1 minus 1.1 minus 5 into 0.3 answer upon 0.4. Did I do some silly error here? 5.1. Yes. So what you need to realize here is this is 0.5 into 10 into 0.3, correct? But I have written delta GP. Delta GP means change in GP. So is GPE increasing or GPE decreasing? What is happening? So here the ball B will be moving downwards, correct? The ball B will be moving downwards. So what will happen is the GPE will decrease because height is decreasing. So this should be, where did it go? Height should be minus 0.3. The height will be positive 0.3, but here it will be considered negative. Why? Because GP is decreasing. What is GP? GP will be final GP minus initial GP. So if the final GP, one second, if the final GP is lesser than the initial GP, then obviously GP should be negative. So hence a negative sign will be placed here. And this 0.5 into 10 into this will become positive if it goes on the opposite side. What I did here is I took 1.1 there. I took 0.5 into this there. I then divided it by 0.4 and then rooted the entire thing to get the answer for V. So yeah, I'll try this again in my calculator. So the answer for V I got is 2.5 meter per second. So what does this answer mean now? This answer means that as the particle, because the particle is accelerating, as the particle accelerates and B moves 0.6 meter down, the velocity at that point for B will be 2.5 meter per second. Now, can you tell me what will be the velocity for A as it has moved 0.6 meter down? I repeat the question. I am telling you, as B travels 0.6 meter down, its speed is 2.5 meter per second. So, what will be the speed of A at that instant? If you are not able to answer this question, watch the video one time again. Watch this question's explanation one time again. Because already told you that if B travels 0.6 meter down and its velocity is 2.5, then even the velocity for A will be 2.5 meter per second. Both will have the same velocity because the string attached is not stretchable. The string is like a stick. So if the velocity of A is something, that will equal the velocity of B. Hence, the distance traveled, the acceleration, the velocity, everything for A and B will be the same. And that's how we are done with this question and we are done with this paper also. Thanks for watching.